Hydraulic system. The number 1 and number 2 hydraulic pumps are driven by separate transmission accessory gearbox modules and supply 3000 psi hydraulic pressure when the main rotor is turning. The backup hydraulic pump is powered by a 115 VAC electric motor. If AC power is available, the backup pump is able to provide hydraulic pressure should one or both hydraulic pumps fail. Each hydraulic pump is a constant pressure, variable volume pump. They maintain the required 3000 psi over any rate of control movement for their own system. However, if the number 1 and number 2 hydraulic pumps are inoperative at the same time, there will be a slight restriction in the maximum rate of flight control movement. This is due to the backup pump's inability to provide the required volume because it exceeds the flow rate capability of the pumps. Each pump has a pressure and return filter. The filters have indicator buttons that extend when the filter is clogged. Additionally, the return filter has a bypass capability, allowing hydraulic fluid to return from the system in the event of a filter clog. If a return filter were to become completely clogged and have no bypass capability, fluid will be blocked in the return lines, causing a hydrostatic flight control lockup. The number 1 hydraulic pump supplies hydraulic pressure to the number 1 first stage, fore, aft, and lateral primary servos and the number 1 tail rotor servo. The number 2 hydraulic pump supplies hydraulic pressure to the number 2, the second stage, fore, aft, and lateral primary servos and the components of the pilot assist area, pitch, roll, yaw, SAS actuators, pitch boost servo, collective and yaw boost servos, and pitch trim assembly. A pressure reducer in the pilot assist module reduces the 3000 psi pump pressure to 1000 psi for use by the pitch trim servo. The backup hydraulic pump can supply hydraulic pressure to the number 1 and or number 2 hydraulic system independently or simultaneously. It is also the only pump that can supply hydraulic pressure to the second stage tail rotor servo and the APU accumulator. The backup pump applies hydraulic pressure to flight control components during ground checks when the main rotors aren't turning. The backup pump will come on and provide pressure when any of the following conditions occur. Number 1 reservoir low, caution light. Number 2 hydraulic pump, caution light. Number 1 hydraulic pump, caution light. APU accumulator low, advisory light. Number 1 tail rotor servo, caution light. An automatic turn-off feature is provided through a switch marked servo off first stage norm, second stage located on the miscellaneous switch panel of the lower console. In the norm position, both stages of the primary servos are on and operating. When the servo off switch is moved to the first stage or second stage position, the primary servos associated with that system are turned off. When the servo off switch is moved to the first stage, fluid to the number 1 forward, aft, and lateral servos are turned off at the transfer module. A loss of pressure in the number 2 primary servos will cause the first stage, turned off but has pressure, to automatically turn back on in case the backup system does not take over the function of the failed second stage. If the second stage is initially turned off, the sequence is reversed. Hydraulic logic. Hydraulic logic uses leak detection isolation, also known as LDI, to protect the flight control hydraulic system by preventing further loss of hydraulic fluid in case of a leak. The hydraulic logic uses pressure switches and fluid level sensors for monitoring pump hydraulic fluid level and pump pressure for primary and tail rotor servos, as well as pilot assist servos. When a pump module reservoir fluid level switch detects a fluid loss, the logic module follows the sequence detailed in the figures on pages 8 and 9 of the Flightline supplement to isolate the leak. To accomplish this, the logic module operates the required shutoff valves to isolate the leak and turns on the backup pump when required. In the cockpit, the RSVR, or reserve low caution, for that system appears. Backup pump and shutoff valves operation is automatic through the logic module. If after the isolation sequence takes place the leak continues, the leakage is probably in the first or second stage primary servos, and the servo off switch must be moved to the first stage or second stage position by the pilot. Logic modules. Two logic modules, one in the left relay panel and the other one is in the right relay panel, are used for the control option of the hydraulic systems. The logic modules continually monitor the operation of the hydraulic systems by inputs received from the pressure switches, fluid level switches on the pump modules, and inputs received from the control switches in the hydraulic system. The outputs of the logic modules will either activate cautions and advisories notifying the pilot of a failure and or turn off one or more of the valves due to system malfunction. All switching functions of the hydraulic logic modules are automatic, except as shown by the dagger symbol in the figures on page 8 and 9, which indicates a required crew member action to complete that step. which references back to the first stage, second stage primary servos. Hydraulic pump. The three hydraulic pump modules on the aircraft consist of a combination hydraulic pump and reservoir that is sealed from the atmosphere. A spring on the reservoir maintains a positive pressure in the system at all times. Because the system is sealed, a servicing hand pump and reservoir are incorporated to allow for replenishment of hydraulic fluid. A selector valve allows the servicing hand pump to be connected to the number 1 hydraulic pump, the number 2 hydraulic pump, or the backup hydraulic pump, labeled number 3 on the valve, or to the rotor brake, which is labeled number 4. Hydraulic fluid levels may be up to 3/8 inch into the overfill zone, which will be black or blue depending on the type of reservoir, when fluid is hot. The fluid level indication is the 1/8 inch wide gold band at the outer edge of the level piston. There are temperature sensitive labels used on all hydraulic pumps. There should be one label on the pressure side and on the return side. When the temperature exceeds 132 degrees Celsius or 270 degrees Fahrenheit on the label, an entry should be made onto the DA Form 2408 13-1. The aircraft should not be flown until appropriate maintenance action has been taken.